Okay, I just want to quickly see something and then okay, so let's start with study unit 8, and basically what we're going to do in study unit 8 today. So we're looking at the confidence intervals. So basically, there's three things that we need to know about the confidence interval. So it will basically be when your standard deviation is known, when your standard deviation is unknown, and then when you are dealing with proportions. So what we will also see, and this is nearly for prep for your exam as well, is that you will probably get in the exam 3 questions on confidence intervals, which will be one for the normal one with your standard deviation known, one with standard deviation unknown, and one for proportions. So just that you are aware of the weight nearly of the study unit for your final exam. Okay, so the things that I just want to highlight nearly is also that when we talk about confidence intervals, we basically always have a lower and upper end. So we most of the instances working with a two-tail, but we'll get into the definitions of one-tail and two-tail more when we deal with hypothesis testing. Just remember that when we deal with, and let me nearly, I just want to add that. So when we look at confidence intervals, you basically always have a lower estimate and an upper estimate. So we're always working with 2 points, and that's why I nearly want to say we're always working with a two-tail. Then the other thing that from the notes that I sent in the week as well, we basically, you will always work with these 3 confidence intervals. Most of the time it will be the 95. It will not be anything else than 90, 95, and 99. So you don't need to worry about that. Most of the time it is 95%. So when we're talking about a 95% confidence interval, the Z value will always be 1,96. Okay, so when we deal with a Z value at a 95%, it will always be 1,96. When we deal with a Z value at the 90%, it will always be 1.645. And when we talk about the 99%, the Z value there for 99% will always be 2.58. Okay, so just, and that is something you can use this later on as a guide as well. So when we deal with the Z value, it is always those 3 numbers that we can use. It is different when we look at the T, but then we need to have a table and those kind of things to work out the T. But if it is a Z, always those 3 numbers that we can work with. So basically, when we look at the confidence of a mean, so when the population standard deviation is known, this is the formula that we work with, and that Z then will be the 1,645 over 1,96 over 2,58. When standard deviation is unknown, we work with the t, and that t you need to get from a table that, again, the tables will be sent before the exam to you as well, but any tables that you have access to, you can use. Then this first part, to get to the t, is your degrees of freedom, and that degrees of freedom is always calculated by the sample minus 1. Okay, so but we'll get to example of that as well. So for the mean, we always have the z and the t. So z when standard deviation is known, t when standard deviation is unknown. Then the other one that we work with is the proportion, and with the proportion, this is your formula. So you will also see that part you would have remembered some of the things that we did previously. I think study unit, was it 6 or 7, where we looked at how to calculate your z. So when we calculated the z for your proportion, you would see that that was nearly that part, or the standard error part of a calculation. So you will also see that when we look at the confidence intervals, the part that you will multiply the z with is your standard error that we had in some of your previous study units as well. So it can be that and that would be interesting to see in your assignments, if they actually at some stage maybe give you, instead of a standard deviation and your sample size, they can also give you a standard error. So this again is nearly for exam preparation, that can be also the standard error. So if they don't give you your standard deviation and they don't give you your n, but they give you a standard error, you can still solve the question. Okay, so that is nearly a bit of background. So let's get into this question. Okay, so a statistics practitioner took a random sample of 50 observations from a population with standard deviation of 25 and a sample mean of 100. The 95% confidence interval of population mean is. Okay, so how do you guys think we will solve this? Is it a z or a t that we will work out?
It is that
okay.
The standard deviation is known.
Cool. From a population with a standard deviation. Okay. So standard deviation is known. We work with a sample mean. So it will be, and I can't always remember that formula, but it will be the x plus minus z times, okay, so with a 95% confidence interval, z is 1,96. Your standard deviation was 25. Your sample was 50. Okay, so that is going to be some weird decimal. that decimal will probably be that, but I am, if you multiply those two out, I think it will be that answer, but let's see. And your sample mean was 100. Okay, so the first thing I want to show you before I want to eliminate some of these answers. So sample mean is 100. So that will be in the middle of your two confidence intervals. So this number here should be more than 100. This number should be less than 100. More than 100, less, so that can work. Less than 100 it should be, so that is definitely not one of the answers. Should be more than 100, not the answer. Okay, could be one of the answers because that is more than 100, that is less than 100, more than 100, less than 100. Okay, so we already nearly eliminated two of the options because with a confidence interval, your mean is in the middle of the two. Okay, so I want to see where is my calculator. Who has played with my calculator that it is gone? Okay. Okay, so basically 25 divided by the square root of 50. So what I normally do as well is, depending on the calculator that you use, it can be that you must just follow the right sequence of how you type it in. So 25 divided by the square root of 50. Okay, why did my calculator not want to do that? Okay, so I get that 25 divided by the square root is equal to 709 or 7,07. Can that be? That is nearly 25. No, that can't be because it will be 25 divided by 7. Okay, no, so did you also get 3,54? If I then multiply that by 1,96, I get that answer is 6.9296, which is exactly that one. So 100 plus minus that. So your top one will be 106.9296. Okay. So that is rounded off, but that is basically the one. Doesn't, okay, see, so that one would have been close. It's just where the decimal is. Interesting, those two numbers, but let's just then work out what is the bottom one. So the lower end will be 93,0704. Okay, so what we can also see is not 93.59, so that is more to see if you have read it on your calculator correctly. So definitely see that is the correct answer. Okay, so the the things that we needed to note here, they talk about population standard deviation. So we know it's a Z. Give us 95% confidence interval, so we know it is 1,96. Okay, and then just by eliminating some of our answers, we can get to a closer answer if we need to guess as well. Okay, questions on this one before we go to the next one. I don't know if any of you have started study unit or assignment 4. So just let me know if this will help you.
Jean, did you say plus 100 plus 692 or minus?
Okay, so for the top one, I say 100 plus the 6.9296, and then for the bottom one, I say 100 minus the 6.9296. Okay, so to get the bottom one, I subtract the 6.9296. To get to the top one, I add the 6.9296. And this is also important nearly because it can be that they ask you a question just for the lower limit or just for the upper limit. Because in a sense, you will also, because what can happen is that you just work it out and you write the two numbers, and then it just makes sense because your smallest one will be first and your biggest one will be second. So that is always the order as well, that your lower confidence will be your smallest number and your upper confidence will be your biggest number. Even when we work with proportions, it will be like that. The other thing is that you also can't get something that's negative. So that is also just important. You will never have an answer that's negative. So whenever you work out something and you suddenly see something is now negative in your calculation, then for confidence intervals, then you know you have made a mistake. Because then it could have been that something in this calculation, the calculator probably worked out the steps wrong or the order of a calculation wrong. But you can never have a negative value for a confidence interval. Okay, is that a bit better?
Yes, thank you. What is the keyword for you to look for when you to discover if it's upper or lower?
Let's see if they have something in these. Otherwise, I will look for one or two examples from previous papers and previous assignments, because I know there was. So I'll if there's nothing in here, I will definitely get you some of those.
Thank you.
Okay, let's go to the next one. So let's go that I shouldn't have had that already. So let's just look at what they tell us from the information given below. Determine 95% confidence interval of a population mean. So this is the information that they give us. Okay, so they give us the mean, the sample, and what is that? That's the sample deviation. Okay, so if we have a sample deviation, we actually don't know what the population standard deviation is. So this is the sample deviation. So because we have a sample deviation, we need to work with the T formula. Okay, so I have now written down the T formula here, but what I normally do is to say X. I don't write all of that down. So I just say plus minus T times your S divided by N, but we need to work out that T. So we need to work out that T from a table, so we will need to go is equal to N minus 1. So N is equal to 100. 100 minus 1 is 99. And then we will need to look for, so let's do that, alpha divided by 2. So how I work with that is I look at the confidence interval. I see it is 95%. So get to the alpha, it is 1 minus the 95%. So remember that percent we can also write in a decimal. So 1 minus 95% is actually equal to 1 minus 0.95. So that we need to divide by 2, sorry. So we're dealing with 0.05 divided by 2. And what is 0.05 divided by 2? It is 0.025. So we will need to look for a degrees of freedom that is 99. And our confidence we're looking at is 0.025. So let me go into the table that I can also just show you on the table how we will look for that. So nearly in the next few chapters, so when we look at confidence interval, we'll need to, for the T, we will need to go to the table. When we get to chi-square in chapter 10, we will also need to use the table. So let me just see if I can quickly get to this. Okay, this is quite interesting. My PDF have changed. And the T table will probably be part of study unit 7 or 8. Let me just get it and then I'll I'm just not sure if it's in study unit 7 or 8, so let's just, okay, so it's study unit. I hope it's not supposed to be there. And this is nearly also why it will be easier if you have nearly all your tables all marked for the exam or have it separate so that you don't need to do what I am now doing, because that will just create chaos for you in the exam as well. So let's just, so basically, I just want to see, can we make it bigger? Okay, so we are looking for the alpha at 0,025, and we are looking for it at degrees of freedom of 99. So there we sit with 2,365. 2,365 that's interesting. Okay, that was just, so we've got 2, so let's just make 100% again. N is 100, so it is 99, 0,025. So let's just, it was that one, 0,025. Okay, 0,025. Okay, so it's 1,984. Okay, so I actually used the wrong one. 1,984. Okay. So 1,984 times your sample deviation of 5 divided by the square root of 100. Square root of 100 is 10. 1,984 times 0.5, because 5 divided by 10 is 0.5. Just put in the plus minus in 200. So again, before we go further, 200 will be in the middle. So this number should be higher than 200. This number should be lower than 200. Lower than 200, fine. Should be higher than 200, it's not. Lower than 200, fine. Should be higher, fine. Fine, fine. Not bigger or smaller, bigger. So at that moment, we sit with 3 that are possible options for us. So 1.984 times 0.5, it is 0,992. Again, it was that one. So 200 plus 0,992 is 200.992. And then 200 minus 0.992 is equal to 199.008, which is that one. So option 3 is the correct answer. Okay, so this was basically when our population standard deviation is unknown. So, and let's do it in the, come on. When that is unknown, we basically need to work with a t. Okay, so when that is unknown, we work with a t. Okay, so that nearly covered the population mean for your confidence interval where your standard deviation is known and your standard deviation is unknown. I think I've got another one that we can look at before we go into proportions in the last few. So let's look at this one as well. So talk about a sample of 25 was drawn from a normal distribution, population standard deviation of 5. Okay. So that is known, so we work with a Z. The sample mean is 80, 95% confidence interval, 95 is 1,96. Okay, so again, 80, so if 80 is your mean, the upper confidence needs to be bigger than 80. So that needs to be bigger than 80, this needs to be smaller than 80. Okay, so your 7,804, okay, can't be. Okay, so let's look at this one. Smaller than 80, bigger than 80 can be a possibility. 80 is your mean, so it can't be this one. So that is probably going to be your confidence interval. What we're going to work out there, but let's smaller, bigger, so that can be an option. Smaller, bigger, that can be an option. But at least two of these are not options. Okay, so let's see what we work with here. So your formula is standard deviation divided by square root of n. Standard deviation is 5. N is 25, so standard deviation or the square root of 25 is 5. So just remember square root of 25 is equal to 5. So basically we're working here with 80 plus minus 1,96 times 5 over 5, which is 1. So we're working with 80 plus minus 1,96. So for your top or your upper confidence limit, it will be 80 plus 1,96. So it's 81,96. And for your bottom, it is 80 minus 1,96. So we are working with 78,04 as your lower confidence limit. So close, but where the numbers are turned around. Close, but where the numbers are turned around. So not that one. 78,04, 81, so option 1 is the correct one. Okay, so again, I think what I wanted to show is how we work through the process to identify if it is a unknown or known population, so that we can know if we need to use a Z or if we need to use the T. If we know we need to use the T, we need to use the T table to get to the answer. Okay, questions before we go to the next one? Okay, so let's then go to the next one. Okay, so let's just look at what they are telling us. simple random sample of 50. Okay, so we know what our N is, has been collected from a population, which is known that the population standard deviation, okay, it's known, so we're working with a Z. The sample mean has been calculated as 240. So again, even before I go further, I know this one will be more than 240. This one will be smaller than 240. Bigger, bigger, bigger. You're all very close. Smaller. Okay, so see there, and that is nearly also what I wanted to nearly get to. So here you will see that number is bigger than that one, and that can't be if you are working out the confidence interval, because your left one needs to be the smallest, your right one needs to be the highest. So in the exam, if I was running out of time and I see this as one of the answers and the opposite, so let's see, is there somewhere 243,5785, 5785, 236.425142, and that's also interesting. So that is also okay. So this is going to be, I think, if I needed to guess between those two, I would have said number one, just because that one was put in there. But let's see. So option 5 can't be, because that needs to be the bigger number. If you look at this one, can't be, because that needs to be bigger than 240 again. So that's basically again the mean, and that is the one that they worked out. So, but 5 and 2 is not options. Okay, so let's look at completing the rest of this. So we're looking for the Z, 95% confidence, Z is 1,96. So 1,96, and then we multiply by the standard deviation, which is 10, divided by the square root of n, so the square root of 50. So unfortunately with 50, we need to now look at how we do that. So again, on a calculator, just make sure that when you work again with a calculator for that specific one, you make sure that the order that you do it is correct. So it will be 10 divided by the square root of 50, and that answer will be 1,8257, and you need to multiply that by 1,96. So if you multiply that by 1,96, you will get 3,5785, which was actually that number again. So your top one will be the 240 plus, so it will be 243.5785, 5785. Okay, cool. So that one is correct. And then your bottom one will be 240 minus that. So it will be 236.4215. So let's just check. And it is that. So option 1 is your correct answer. Okay, so again, basically using your confidence interval formula, identifying that the standard deviation, as they also told you, is known. So you know you need to work with the Z values. We know that 95% confidence interval gives us the 1,96. So then you can use the rest of the formula to get to your answer. Okay, so the last two will be on proportions. So let's just find thus far. Is it making a bit more sense to you guys when you started off with the study unit? So that at least I know that it helps. Okay, so let's go into the next one. So let's see. Okay, so both of them gives us a top and bottom. So I will definitely look for one or two examples where they only want the lower confidence level or the upper confidence level. Okay, so let's look at a random sample of 80 observations results in 15 successes. The 95% confidence interval for the population proportion of successes. Okay, we're working with proportions. So when we're working with proportions, it will always be a Z. So that is when we're working with proportions, it will always be a Z. We're working with 95, so your Z will be equal to 1,96. Okay, so that is the first thing. So what is your, and I can't remember this formula, so I will just copy this over quickly. And that is also, so you can use this template in the exams and everything. You really don't need to remember these formulas at all. Okay, so that is the formula that we're going to work with. So we first at least need to work out what is P. So P is your successes as a proportion. So it is 50 divided by 80. So 50 divided by 80 is 0,625. Okay, so the same applies in this instance, that your upper confidence level will be more than 0,625, and your lower confidence level will be less than 0,625. So when we look at options, okay, so that one is wrong. So again, that was your mean. That is probably going to be the one that you plus or minus. Okay, but let's look. That's bigger. That's less, so that works. 6,2. Ooh, just bigger, just less. 0,73, bigger, less. Again, turned around. And that should be your bigger, should be smaller. So the two that I can eliminate beforehand is option 1 and 5. So let's look at what it is. So 0,625, that is your mean. So let me just 0,625 plus minus, we know Z is 1,96. the P is 0.625. 1 minus 0.625. So that is equal to 0.375. 375 divided by n, which is 80. So again, depending on which calculators you use, just make sure that the calculation beneath the square root you're doing correctly. So it is 0.625 times 0.375, which gives us, so I just want to, let's just do that, 0.2343 or 44. So if we divide that by 80, I get 0.0029, and then you still need to take the square root of that. So let's just make sure that we do that. Remember 1.96 there as well. So if we take the square root of that, we get 0.0541. If I multiply that by 1.96, so again, there can be mistakes happening as one multiplies and adds, and because again, depending on if you use brackets or not and which calculator you're using, it is easy to make that mistake. So let's just, it's 0.625 plus minus 0.1061. So again, depending on how we would have rounded off, that could now be 0.1061 or 0.1060. Okay, so then for your top one, we need to say 0.625 plus that, so 0.625 plus 0.1060888 is 0.731. Okay, so I am getting that 0.731, and then if I say 0.625 minus 1.1061, I do get the 0.519. Okay, so option 4 is the correct one. So with this one again, just remember when we're working out population proportion, it is always a Z. Okay, so the only time that we're not using a Z is when we have when we're looking at population mean, where the population mean is unknown. Okay, so let's look at the last one. So according to statistics reported on Stats SA, rising number of motor vehicles are not covered by insurance. Results consistent with the Stats SA report showed 46 of 200 vehicles were not covered. The 95% confidence interval estimate for the population proportion. Okay, so let's just to get that again, because we will need to use that formula. Okay, so let's first look at, so let's use a different color this time. Okay, so the P that we are working out there, so nearly look at it again as the successors. So in this instance, we are looking at not covered. So the not covered is 46 of the 200. So 46 divided by 200 will give us that P value plus minus Z. So 95% confidence interval is 1,96. So we can work with that. Time. So let's also just work out the P. So if we say 46 divided by 200, we get 0,23. So if that is 0,23, 1 minus 0,23 is 0,77. And we will divide that by n, which was the 200. Okay, so just again, so that basically the P is equal to 0,23. So when we look at confidence interval, the upper confidence need to be bigger than 0,23, lower one smaller. So let's look at options, bigger, smaller, that can be, smaller, bigger, can't be. Yes, it is bigger, so it can be, it should be smaller, it can't be exactly the same. So it can't be, should be bigger, should be smaller, can't be. If I look at that option, I would have probably picked that one. But let's look at the next one. Bigger, smaller, so it can be. So if I just followed this principle, I only have two options left that I can pick out of. So again, nearly just giving you the hint how to look at this. But let's now work this out. So 0,23 times 0.77. So I get 0,1771. I need to divide that by 200. So I get 0,00088855. If I take the square root of that, I get the answer of 0,02975. So I'm just going to, and it continues, so I'm just going to multiply that by 1,96 while I have it. So 0,23 plus minus 0,0583, and probably writing too many numbers, but 0,23 plus that is my upper, so it's 0,2883. Okay, so there, I see I made it should have been a 4. So I just want to, that should be a 4, so that can be a 4. So again, that's just rounding off. You won't get in the exam that you have one answer of 0,2884 and one of 2883. So you won't have that in the exam. And then the bottom one is 0,23 minus that. So it is 0,1716. Okay, which is that one, yes. Okay, so option 1 is the correct answer. So basically, what we went through is to say, if we know what the population standard deviation is, we can get the confidence intervals by using the formula that we can use Z. When it's a Z, we know that your confidence interval, when it's 95%, your Z is equal to 1,96. When the standard deviation is unknown, we need to use the T. And when we work with population proportions, we can always use the Z. We only use the Z. And then again, the standard process follows that if it's a 95% confidence interval, the Z is 1,96. Okay, so that is study unit 8, everyone. Some feedback. Is it a bit clearer? Are you guys now only going to start looking at study unit 8? So how are you planning to do this? Or is it just trying to get all of the new things into your head and see how you're going to use it?
I think the concept that you've given us, or the tips that you've given us, it makes it a bit more clearer to understand what you're reading. And maybe just going over the videos again, it will help a lot.
Yeah, cool. Thanks. Yeah, I also think when you, nearly before you do the assignment, nearly look at, we'll do the next study unit next week, so that you can just look at both videos nearly and then be ready for the assignment. And keep the one-pager document that I've also circulated on the WhatsApp group last night. Keep that with you the whole time, because that nearly tells you the whole process that you can also do. Okay, if that is when it, guys, will definitely do study unit next week, so that you still have enough time to complete assignment 4, and then we will start. Maybe I'll do a recap of assignment 2 or 3, or we just start with assignment 5. They've said that the chances of assignment 4 or 5 being extended is very slim, as all the assignments need to be finished by the end of August. So yeah, so I don't think assignment 4 will be extended. So just be prepared for that and make sure that you complete assignment 4 beforehand. Okay. Thanks, everyone. Have a good evening.
Thank you.
Thank you.
Thank you.